In this lesson, we're going to continue our work on big idea number 1 and 2, how are organic compounds classified and how do their structure determine their properties. Today we're going to talk about alcohols, alkyl halides, ethers, and amines. An alcohol is a hydrocarbon with a hydroxyl functional group. They have the general formula ROH. R stands for the hydrocarbon. As this box explains, when writing expanded molecular formulas for alcohols and any of the following families we'll discuss in the course, start at the end of the parent chain furthest away from the functional group. This makes your expanded molecular formula like the general formula for the family, where all your C's and H's, your hydrocarbon chain, comes before your functional group. It makes it easier to identify which family your chemical is in if you're only providing the expanded molecular formula. Alcohols are classified based on how many hydrocarbons are attached to the C bearing the hydroxyl functional group. Primary have one C attached to the C with the hydroxyl. This means that the functional group will always be at the end of a chain. Secondary carbons have two carbons attached to the carbon with the functional group. This means you'll see the OH in the middle of a chain. And tertiary alcohols have three carbons attached to the carbon bearing the OH. Don't get this classification system mixed up with how we classify amines and amides. To name an alcohol, follow the hydrocarbon rules and use the suffix ol, ol. Hydroxyl groups take numbering priority over other alkyl groups, but not double and triple bonds. Means that if your compound has a double or triple bond, it gets the lowest number, followed by the OH, if possible. Number 3, add a position number to the hydroxyl group in front of the suffix. Number 4, if more than one hydroxyl group is present, use a molecular prefix to indicate how many. And if the suffix begins with a vowel, drop the E on the parent name. It makes the name flow better when spoken. Here are some examples. The parent chain on molecule A is the three carbons going horizontally across the page. That corresponds to a prop as my root. And they are bonded together with single bonds. So this would be propane in the alkane family. Now, to indicate that there is a hydroxyl functional group on the molecule, I would add the position number 2 and ol. Following rule number 5, if the suffix begins with a vowel, I will drop the E on the parent name. This gives molecule A the name propan-2-ol. Pause the video and take some time naming molecule B and C. Here are the answers for molecule B and C. The main chain for molecule B is the 6 carbons going horizontally across the page. I have to indicate that there are 3 hydroxyl groups. In order to get the lowest possible number, I would start numbering my parent chain in this direction. Because I have a parent chain of 6, my root will be hex. I have all single bonds, so ane. To indicate my hydroxyl groups, I have a position of 1, 3, and 5, I have 3 hydroxyls, so it gives me a molecular prefix of tri and then all. Because my suffix does not start with a vowel, T is a consonant, I leave the E in the hexane. The final name is hexane 1,3,5-triol. Molecule C. My parent chain is the 4 carbons going horizontally across the page. I have to indicate there is a double bond and a hydroxyl group on this molecule. Because I have 4 carbons, my root will be bute. And I have a double bond, so I will use the suffix -ene. Now I need to label my chain so that the double bond gets the lowest possible number. Because double and triple bonds take numbering priority over any other functional group. My double bond is between carbon number 1 and carbon number 2. Now to indicate the hydroxyl, it is also on carbon number 1, and then following rule number 5, because my suffix ends in a vowel, I need to drop the E on the parent. The final answer is but1-ene-1-ol. Properties of alcohols. Hydroxyl groups are polar and can create hydrogen bonds because there's an H directly attached to an O. This means that alcohols have higher melting points than alkanes. For solubility in water, the OHs are polar and allow an alcohol to make hydrogen bond with water. This gives it a higher solubility than alkanes. Other information about alcohols. They're mainly used as solvents, also antiseptics, and a main component in antifreezes. They are extremely flammable, so when you work with them in the lab, we usually use hot plates instead of Bunsen burners. All alcohols are poisonous, including the one found in beverages, ethanol. They can cause blindness, impairment, and death if you're exposed to too much.